Now there are two numbers that are often used to describe a given wind farm, a given wind turbine. One is the specific area ratio, SU. This is telling you the amount of power per unit area you got, or precisely the amount of area you need to generate a particular amount of power. So it's the swept area divided by the generator power. And it depends on the class of turbine. So if we take a class 1 turbine, it's going to need less than 3 square meters to generate every kilowatt hour of power, whereas a class 3 needs more than 4 square meters to generate a kilowatt hour of power. What this means is, if you want a 3 megawatt turbine, it's going to be less than 107 meter blade if you class 1, whereas you need more than 124 meter long blade for class 3. It needs a bigger area to get the same 3 megawatts. If, on the other hand, you fix the rotor diameter at 100 meters, then you can see the power is different. A 100 meter thing will get more than 3.2 megawatts if it's class 1 and less than 2.4 megawatts if it's class 3. That's one number. Another one that's often bandied about is the turbine capacity factor. Now the capacity factor is the average power produced by a wind turbine over some time divided by the rated power. That's the maximum power it's designed for. It's not the same as efficiency. Efficiency is the power divided by the power in the wind. This is power divided by the power in the maximum that the turbine is designed for. If you design your turbine for a lower power, you'll have a higher capacity factor. And this capacity factor basically depends on how windy it is. Here's a graph we've seen before for the Woodlawn wind farm, and you can see it's up near 100% capacity factor around here, down near 0 there, and on average typically between 25 and 50% capacity factor for Australian wind farms. The evolution of wind farm sites in Australia, the very first wind farms are put in the windiest places. So in these places, you want a windy place that's also close to a transmission line, so you can get your power back to where it's needed. It's far too expensive to put transmission lines into a site which doesn't already have them nearby. But the best wind farm sites, the very windy places with near transmission lines, by and large all been occupied already. So now as we go around Australia, we're getting more and more trends towards less windy sites. A trend away from class 1 but towards class 2 and class 3 sites. And this is happening around the world, and the class 2 and 3 turbines are undergoing a rapid development. The blades are getting longer and longer, greater swept area captures more wind and generally achieves a higher capacity factor. So it's now actually possible to get a higher capacity factor at a class 2 or class 3 site than you can at a class 1 because of this new technology and the very, very big turbine blades and ever-increasing hub heights, which pushes you high enough to get into the wind. So new wind farm capacity factors are often higher than the old wind farms despite being located in less windy locations, which is actually very good if we need to ramp up the amount of wind farms around the world to decarbonise. It means we don't have to stick with the very windiest sites. Here is the graph of the month of the year for different years against the typical wind capacity factor, and you can see it's normally sitting between 30 and 40%, and there's a general trend where the capacity factors are lower around March or April. There's just less wind that time of year, and higher around July, August, September. You get different figures depending where your wind turbine is going to be.